Okay, we now have two speakers. James Lucas is going to speak first, and then Li-Bing Chen. Both are talking about the environment that they've built.
Good morning. As I said, my name is James Lucas, and this is Bing. We work for the Faculty of Engineering and IT at UTS. As part of our courses, we run both Cisco and Alcatel courses, and also certification short courses for them. The environment is made up of 5 specialised computer labs. Each of those is 24 to 30 computers, and they're based on Fedora and Xen. These labs provide practical hands-on learning experience for internetworking, and this includes routing, switching, security, wireless, and VoIP. Yep, oh no, you've gone too far. So, in a typical networking lab setup, students will use, as a group, a couple of workstations, running generally Windows for the networking, and a Linux machine running Cisco Eagle Server, which provides various network services. From that, they'll have physical network connections and serial connection through to racks of networking equipment, which they will configure as part of their labs. The students need full access to all of these machines to install software, reboot, configure the network, run network analysis on it. These computers also have the problem that they're connected to the internet. You'll need access to the internet, but we want to keep that lab traffic off the production network at the same time. Also, as in any teaching environment, all of these technologies are shared by the students. So when a student leaves a lab and the next one come in, which is generally with no break, we need to be able to quickly reset the environments, change between different environments, and it needs to be immediate. We also have the extra problem posed by hardware cards such as Cisco wireless cards, which need to be passed through to these environments to use, which is what Bing is going to talk about more.
The limitation of the previous setup is that we use some add-on just reboot card to achieve the quick system reset. There's also, when we need to run another image, we have to use a swappable external hard disk to put up to another operating system. And also, because of that, we have to frequently swapping the hard disk and the live CD. So sometimes we can get into the trouble. So every time we start the labs, we have to provide the academic with extra hard disk and extra CD, just for that. So around 2009, when we upgrade the networking labs hardware, so we're looking for another solution. So because we already run the virtual Windows image on our general labs, so we are thinking that we maybe do the same thing on the networking labs. Basically, it's like what virtualization can give us is that they can provide clean and environment. This is to be done by, we provide each user their own copy on write image, this image file. So in this way, each user, each user's modification will only write to their own copy on write image, this image file. So will not affect another users. Also, is because we use a virtual environment, or the OS is this image we can put into the local hard disk, just switch from a menu. because running in a virtual environment, even the user, student, they change the network setting in the virtual machine, we still can access to this VM through the host system. As James mentioned before, we have some sticking problem with how we do with the wireless network card we use in the networking labs. The way we do it is we pass through the physical PCI pass devices to the virtual machine directly. In order to do this in a fully virtualized virtual machine, we need some special hardware features built into the modern computers. This is IOMU. It's similar like the traditional memory management unit. It will translate the device visible address to the physical memory address. So we look at that. This is the figure we emulate in the lab virtual machines. You can see here is a traditional emulated network card. The virtual machine only sees the emulated network card. All the actual network operation is intercepted by the hypervisor, then passed to the physical network devices. So the virtual machine doesn't know what physical network card in the host. With PCI pass-through the PCI devices, here we can see a wireless network card. The hypervisor will present the physical devices to the VM, and the VM will use the native driver to talk to the virtual, to talk to the device address of the PCI network card. Then the IONU will to the actual physical address to finish the operation. So when we do this setup, we test both KVM and SAN type virtualization solution. We choose the SAN because it's widely used and proof open source virtualization technology, have a very active community. I think the most famous user will be the Amazon. They build a whole public cloud on top of SAN. And also, this is actually the main reason we choose SAN over KVM, because at the time when we set up this networking labs, the wireless network card we're using is actually share the IRQ with the USB controller of the motherboard, and doesn't support the PCI pass-through for shared IRQ devices. As mentioned before, that we use the QEMU CAL formats to do the user session files. So how we do this, make all these screw up together. We create a GUI, simple GDK GUI application called VM Chooser. You will do the user authentication and press select menu for the user to select which VM to launch. This is we can skip that. With the fixed setup, we use a VNC viewer as the user interface. The student has some complaint about the the video performance is not very good and using a VNC, so we make another change to use VGA pass-through. Basically, it's like we do on the networking cards. We pass through the VGA video card to the VM, so the VM can get the near bare metal performance as we use in the host. The one problem with the VGA pass-through setup is how can we do the user authentication and let them choose the VM. The way we do is we start a VM, start a daemon at the host, and what it is, we will check if there's any VM running. If there's no, we will put up a Fedora VM, which runs the VM chooser. Then user can use log into this Fedora VM, authenticate, and make a selection of the running VM. Then we will pass a message back to the host. Then the VM starter will pick up the message and shut down the Fedora VM, then start the select VM the user choose. After the user finish and the VM starter will check again, and because there's no VM running at the moment, it will start the Fedora VM again, then do another job. Besides that, we also set up another alternative option for the networking labs. Since CERN 4.2, they support the SPICE protocol, which is similar like the VNC, it's a remote desktop protocol, but it has much better GUI performance than the VNC. And it also make it possible for the user to access the VM through a HTML5 capable browser. Next, I will do some demo on our setup of the VM chooser. First, we need to know how we do the PCI pass-through setup. You need a system that supports the IOMMU. So and you can see there's when CERN boots up, my system doesn't support the I/O virtualization. So, but with a system that supports it, we see here we say the I/O virtualization is enabled. Then you need to tell the CERN that which device, PCI device you want to pass through. See, what this script do is actually run a CERN command, XL command to add the select the PCI card to the CERN PCI back kernel module, so that in this way the CERN aware of which PCI device you want to pass through to the VM. And in the send configuration file, here you put the PCI device you want to pass through in here, which is my system doesn't support it, so I'm coming out. And then you can just put the what we run on the machine, net machine, is we run this VM chooser login menu. Then user just put their and choose the VM from this drop down menu. You can see that we can just start the normal VM session, or we set it to the pre-stream mode. Let's do that. And after the user click login, it will find up a Spice client. So the user can use the Spice client to interact with the virtual machine. So there's some reason why we choose open source, because we run out of time. Just skip to the question time.